topic that we would be discussing today is photolithography. It is the technique by which we transfer the patterns on the surface of the substrate. So here you see that this is the substrate and this is the photo mask, generally known as mask. And let's say our substrate is in this form. We have a silicon substrate on top of which we have deposited silicon dioxide. And we want a feature on the silicon dioxide layer. On this layer, we want to make a feature, meaning that some portion of silicon dioxide we want to etch, while the remaining portion we want to have on the substrate. So for that, what we have to do, we have to use photoresist. We have to use photoresist, and we have to use the photo mask. So these two things should be used to transfer the pattern from the photo mask onto the substrate. So how it is done? So first you have to make the photo mask. तो पहले हमने क्या करना है? We have to make a photo mask. So generally also known as इसको mask भी कहते हैं. So first, actually we have software for making the mask layers. We have the software. So the feature which you want to make on the substrate, or the feature you want to have in each layer or in each process, for that feature first you have to make those features in a software. और कौन से सॉफ्टवेयर अवेलेबल है? वन ऑफ द सॉफ्टवेयर इज MEMS Pro, Aladit, Coventerware. So these are the software. First you have to go there and you have to make the drawing of the feature, the top view. We call it layout. The top view of the feature which you want to have on the substrate, or on which you want to make on the layer. So first of all, you have to make the layout, top view of that feature in the software. Then you have to send those files to the mask manufacturer. Throughout the world, there are a number of mask manufacturers. You have to send your files to them, and they have to make the mask for you. So mask जो है, mask manufacturing आपने खुद नहीं करना. Normally there are special companies which have the expertise, which have the machine, and they would actually fabricate the mask. So mask जो है, normally market में if you are buying or making the mask, two masks are available. One is the glass mask and the other is the transparency mask. Glass masks are expensive. They are expensive, but they are long lasting. Their life is more. On the other hand, the transparency masks, they are cheap, low cost, but you could use the transparency mask for one or two runs, and after that it would be unable to use it. So its life is short. So transparency mask की life short होती है. Glass mask you could use it for years. They are expensive. But remember that you will be not making the mask. You have to make the drawing of your features, and then you have to send the drawing. The drawing was drawing from layout. We call it layout of the your device. So the number of processes or number of layers जितने आपने deposit करने, the same would be the number of layouts of your process. So first you have to make the photo mask. Let's say we have this a photo mask. So it is a glass mask. So glass mask the feature, let's say ये feature हम transfer कर रहे हैं, you are seeing that. So that would be opaque to light. This portion on the glass mask would be opaque to light. यहाँ पर हम chrome deposit करते हैं. It would be a mirror, just like a mirror. We will deposit a chrome. So when the light comes, the light would pass to the other portion of the glass mask. However, this portion is reflective, so the light would reflect back and it would not pass to this portion of the mask. So we would have a photo mask, and then we would have a photoresist. Photoresist is a highly sensitive material. It is in the form of liquid, viscous liquid. So we have to spin coat the photoresist on the wafer. So we would have a spinner machine. Spinner machine होगा. Spinner machine से you have to put your wafer, and then you have to dispense the photoresist, which is in the liquid form. You have to rotate the substrate uh, at a speed from 1000 to 1500, and we have to pour the photoresist. And when we pour the photoresist and the substrate is rotated at high speed, the photoresist would spread on the wafer or the substrate, and a thin layer of the substrate, a uniform thin layer of the photoresist would be formed on the substrate. Here you see that we have a substrate, silicon dioxide. On top of it, we have deposited silicon dioxide. And for the photolithographic process, we have deposited or spin coated the photoresist. Photoresist is highly sensitive to UV light. When it is exposed to UV light, its chemical properties changes. So the photolithographic process है, it is analogous to photography, old photography. The photography in which we have developed the negative and then the positive. So उसके analogous है. So the photoresist is highly sensitive to UV light, and its property changes when it is exposed to UV light. Let's say we have this photo mask, and beneath we have a substrate containing the photoresist, and we are exposing our substrate to the UV light. So normally we have a machine which is known as mask aligner, and in the mask aligner you have to put the substrate at the bottom, and you have to put the photo mask at the top, and you have to bring these two. Both of these must be touching each other. Here it is exaggerated. Here you see that the photo mask is not touching the substrate, but in reality they would be located very close to each other. In reality they would be touching each other. So then in the mask aligner, we have to push a button so that the UV light, ultraviolet light is incident on the photo mask. So when the ultraviolet light is incident, so the portion of the mask which is reflective or opaque to the light would not pass through. Whereas on the remaining portion, because it's a glass or transparency mask, the light would pass. The light would pass. So here you could visualize that this portion, the white portion of the photoresist is exposed to UV light, whereas the black portion is the unexposed photoresist. The photoresist which is exposed to UV light, its chemical properties would change. So the chemical properties of the white portion photoresist would be different now, and the chemical properties of unexposed photoresist will be different. Now again, we have two types of photoresist: positive photoresist and negative photoresist. So if you are using positive photoresist, the outcome would be different. And if you are using the negative photoresist, the outcome would be completely reverse of that. It would be different or reverse of that. So if positive photoresist की क्या definition है? The definition of the positive photoresist is anything which is exposed, it would be removed, it would be gone. Anything which is exposed, it would be removed. This is the definition of the positive photoresist. Negative photoresist, anything which is exposed, it would stay. It would stay. So you have to remember the definition of either for positive photoresist or negative photoresist. So if keep in your mind the definition of the positive photoresist, just remember that the negative photoresist is the reverse of the positive photoresist. For example, If you keep in mind that the definition of the positive photoresist is anything which is exposed to UV light, it would be etched out, it would be gone, it would be removed. So this is the definition of the positive photoresist. Negative photoresist का reverse है, anything which is exposed, it would not go, it would not go, it would not etch out. So if you are using positive photoresist and then you put in the developer solution, next we have to put the wafer, we have to put the wafer in the developer solution. We have to develop the photoresist. The process is known as development of photoresist. We have to remove some portion of the photoresist. Here, if it is a positive photoresist, the portion which is exposed, it would be etched out in the developer solution. Developer solution, वो portion खा लेगा, it would eat that portion which is exposed to UV light. When in a beaker, developer solution would be in the liquid form. In the beaker, you have to put the wafer. So the developer solution would eat that portion which is exposed to UV light. Only that portion would remain which is unexposed to the UV light. So the same pattern which is here, you could see that the same pattern which is on the photo mask, the same pattern has been transferred on the substrate. Now we have this on the substrate. We have transferred the pattern. This process is known as photolithography. So next हमने क्या कर रहे हैं? Next हम ये photolithography कर क्यों रहे थे? Because we want to etch some portion of the silicon dioxide. We want to etch some portion of the silicon dioxide. So here you could see that this portion of the silicon dioxide is unexposed, and this portion of beneath the photoresist, the portion of the silicon dioxide is exposed, or it is protected by the photoresist. So next we have to etch out, or we have to etch the silicon dioxide. So silicon dioxide को etch करेंगे. So normally we use the dilute solution of hydrofluoric acid. Hydrofluoric acid actually eats the glass, or it eats the silicon dioxide. So normally when you, after this, when you would put your wafer inside the HF solution, dilute solution of hydrofluoric acid, the hydrofluoric acid would not eat the photoresist. It would not eat the photoresist. However, on the other hand, it would eat or etch the silicon dioxide. So the same feature which we have transferred from the photo mask onto the substrate, that is on the substrate with the help of the photoresist, the same feature now we have here on the silicon dioxide layer. And next, at the end, as the process is almost complete, so we have to strip off the photoresist. There is now no need of the photoresist because we have already transferred the pattern from the photo mask into our silicon dioxide layer. So there is a stripper solution. For each photoresist, there would be a developer solution. For each photoresist, there would be a stripper solution. So we would put our wafer, next we have to put our wafer in the stripper solution. The stripper solution would etch or etch this photoresist, unexposed photoresist. We would etch that photoresist. And at the end, what we would have, at the end we would have a substrate or wafer, and on the top we would have a silicon dioxide feature. So this is a silicon dioxide feature. In the process, what we have done, we have transferred the feature from the photo mask onto the substrate in the silicon dioxide layer. Conversely, if we have a negative photoresist, then as we discussed that negative photoresist, the outcome of the negative photoresist would be the opposite of the positive photoresist. So anything which is exposed, it would stay. So here, the portion which is exposed to UV light, it would stay. So when we would put the wafer into the developer solution, so anything which is exposed, it would stay, and anything which is unexposed, it would be etched out by the developer solution. So now we have developed our wafer. This is known as developing of the photoresist. We have developed the photoresist. Next, we have to etch the silicon dioxide under the protective layer of the photoresist. This is a protective layer of the photoresist, and we have to etch the silicon dioxide. So silicon dioxide is etched, and finally we have to strip off the photoresist. So we have to put in the stripper solution, and the stripper solution would etch the photoresist. And at the end, we would have the substrate or wafer, and on the top we have a feature of silicon dioxide. So you could compare the final outcome. If you have positive photoresist, this would be the outcome. If you have negative photoresist, this would be the outcome. Although the mask is same, although the photo mask is same. Photo mask same hai, but the outcome is completely different. So it is very, very important that before starting the fabrication process or designing the fabrication process, you must know photoresist, which type of photoresist you would be utilizing. Either you would be using positive photoresist or you would be using negative photoresist. ठीक है, तो बेसिकली arbitrary आपने select नहीं करना बस कि भाई you went to clean room and you just saw a bottle of photoresist and you pick it and you start your process. First, you have to look at the instructions which are written on the bottle of the photoresist, and you have to check whether it is positive photoresist or it is negative photoresist. And you have to, before actually designing phase में आप लोगों ने, when you are making the layout of the layout which you are making in the software, there you have to decide that whether you would be using positive photoresist or negative photoresist. You are making the photo mask for the positive photoresist or negative photoresist. So during that phase, when you are making the drawing or layout of the photo mask, you have to decide about the photoresist. And depending upon that, if you have decided that my photoresist will be positive, then you have to make the drawing of each photoresist, right? So it is very, very important that you must know before in hand what type of photoresist would be you would be utilizing, positive or negative. Based on that, you have to make your layout. Based on that, you have to make your photo mask. And when you are starting the process, you have to make it clear or confirm that you are using the same photoresist for which you have made the photo mask. Otherwise, you would end with different shapes. Otherwise, if you want this pattern on the substrate, but at the end when you would finish the process, you would have this shape on the substrate, and you would ruin your wafer, you would ruin your process, and you could ruin your device. So again, here photo-lithography, objective, pattern transfer, analogous or analogy photographic process. So the old photographic process where we would be using the reel, हम reel use करते थे, and on that reel there were photoresist, reel के ऊपर photoresist, and that process was completely analogous. Photolithography is analogous to that photographic process. So in the camera, we develop the negative, and then we give that reel or negative to the photographer, and the photographer actually develops the negative, and he comes out with the positive. And our old photographs are actually the positive of that negative reel. So that photographic process have been actually the knowledge of that photographic process have been used or utilized to have this photo-lithography, where and we are transferring the pattern from the mask into the substrate. So here you see the same process. Here, this is the substrate. This is the thin film which we have deposited, and we want the pattern on this thin film, meaning that some portion of this thin film we want to stay on the substrate, and some portion of this thin film we want to remove. So first we have to make the layout of the feature in the software, that is, and then you have to send that to the mask manufacturer, and the mask manufacturer will manufacture the mask. So let's say this is a glass mask. This portion is opaque to UV light, while the other portion, remaining portion, is transparent to UV light. So when you would put your substrate, and on the top of the substrate, you have to spin coat the photoresist. So this is the photoresist, and then you have to put your wafer inside the mask aligner, and you have to put the substrate, sorry, you have to put the mask inside the mask aligner, and in the mask aligner you have to expose your wafer to the UV light under the glass substrate. So UV light would pass through the transparent portion, and it would be reflected back by the opaque. So this portion of the photoresist would be exposed to UV light. However, this portion would be unexposed. And assume that if it is a positive photoresist, then anything which is exposed, it would be etched out when you put in the developer solution. Next, we have to put this in the developer solution. So anything which is exposed to UV light, it would be eaten out or etched out by the developer solution. So developer solution would eat this portion, and this portion. The portion of the positive photoresist which is unexposed, it would remain stable. It would be there. So next you have to etch out this layer under the protective layer of this photoresist. So we have to put this into another etchant solution which would eat this layer. So as this portion is exposed, so it would be eaten by the etchant solution. That portion will be eaten, and this portion will be eaten. So on the substrate, we would have this portion of the thin layer, and we have this portion of the thin film. So the same pattern which we have on the mask, it will be transferred to the substrate. This process is known as photo-lithography. So normally in microelectronics, microfabrication, MEMS, we develop the device layer by layer. Next, we will put another layer, and then we will repeat again the whole process of photolithography and etching. So we have two types of photoresist: positive photoresist and negative photoresist. Also, we could classify the photo mask. We have glass photo mask, and we have transparency photo mask. Glass mask, here you see the glass mask, we have a quartz glass, and on it we would deposit, the manufacturer would deposit the chrome layer, just like a mirror. In mirror we have deposited the thin layer of chromium. So we have to deposit, the manufacturer would deposit a thin layer of chromium, and that would define your feature. So feature आप जाते हैं, so the manufacturer would make those features by depositing a thin layer of chromium. So this portion would be highly refractive to the